analysis, statistical analysis. Then once the risk analytics will give the insight about your data. And second thing is, second thing is diagnostic analysis. So diagnostic analysis is why it happened. Okay, that you have to why it was happened. So what happened, you can do mathematical analysis. Why it has happened, you can do again it's saying that recordings. Okay, then after the diagnostic analysis, then you can have a predictive analytics. What will happen? Then the last one is prescriptive analytics to make it happen. Okay, so this is why if you talk about the different analytics component, the first one will talk about descriptive, then second one is talk about diagnostic, why it happened, what will happen, we'll talk about the predictive, then the last one is talk about prescriptive. Okay, so these four analytics, all data science is coming under the four analytics. So each analytics handling with various algorithms, how we are going to predict, how we are going to classify, how we are going to forecast. That way, there are different algorithms are there in each category. So let us, confine with a kind of algorithm which is regression models that we will discuss now. Which we discuss now. Actually, where we can have different regression modeling. So you wanted to talk about fundamental mathematical model. You are all aware that the mathematical model is representative of some phenomenon. Okay, that is not the mathematical. So mathematical model always talk about how I can represent an activity in a mathematical formation. So how I can represent the activity in a form of equation, maybe a process in form of equation. So the process delivers a product in the form of, for any phenomenon I wanted to bring the representation of an equation or a model, mathematical model, then that equation is called mathematical. So it is completely in the form of expression. For example, you are aware that I wanted to put the value like this. I wanted to put the X graph, Y graph. I am plotting some data. So once I am going to plot some data, then I wanted to know how the values are playing. So for that, you are all aware Y is equal to mx plus c, like you are all aware of that. So how that I can bring this particular event into form of expression. So that is the mathematical equation we have to build. Then when we do this mathematical equation, there are different variables are playing role. Variables are this is the resultant variable, or I can say this is the dependent variable. So these are all the independent variables. So based on this variable will change. So like there are a relationship between lot of variables and the result will be takes place like that. Then in this mathematical model, we can say that one model is called deterministic model and another model is called the probabilistic model. So what exactly deterministic model is? If your model give the exact result, then I can say that model is a deterministic model. So I can have some set of variables. For example, if I say f is equal to m, so where I can have a set of variables like m comma a. So in the m comma a, if I assign, then it is nothing but the force. So force is clearly defined as m to a. I cannot say that the force may be multiplication of some value and it will give something like that. Okay, I cannot give some probability for it. I can say that exactly how that value I can calculate with the help of the equation M into A, right? So once I say this is completely a equation which is a defined equation, this always give the exact value. This always will give the exact. So whenever you can have, for example, I can have one equation like a quadratic equation. I wanted to find out x squared minus 5x plus 6. So if I say x squared minus 5 plus 6, where I wanted to find the roots of equation, always the root equal to 2, 3. So if I say 2, 3 are the roots, then that's a defined roots I can have. So such a thing, or I wanted to say that any equation minus b plus or minus square root of minus 4a by 2a, like if I have that value, so that is a defined formula to get the things. So in that scenario, we can say that the model is deterministic model. Hypothesis exact relationship. Okay, there is no what is called a probability for that. There is no prediction error. There's no prediction error. So such kind of a model. Then another kind of a model is called probabilistic model, where we can have two kind of component. One is a deterministic component, then one is the random error. For example, I wanted to set the sales volume y is equal to into advertisement cost plus some random error. Okay, so here this sales outcome will depend on the advertisement cost, but not only depend on that advertisement cost, also depend on the random error. Okay, so this random error, if it is negligible, then I can say this is a hypothesis is exact value. But in the real-time scenario, we cannot say, we cannot ignore this error. In the real-time scenario, we cannot ignore the random error. Since we are unable to ignore the random error, then this will also play a part on this calculation of the sales volume. So by the way, I cannot exactly say what is the income, because in one scenario this may be good, in another scenario this may not be good. Okay, one scenario this may be good, in another scenario it may not be. So in this situation, we can say that model is the probabilistic model. We can say that model is a probabilistic model. Okay, fine. So in the probabilistic model, you can have a two. What's called regression model. The second one is called correlation model. Okay, how the correlation of the variables. Then this model only we are going to discuss it. This model, the regression model only we are going to discuss. So model coming under the category of probabilistic model. So regression analysis is a form of predictive modeling. Okay, so already we have got different modeling, that is descriptive, diagnostic, predictive, and prescriptive. For modeling, I told you. So this will come under the predictive modeling. That is why I have some already a few, little bit introduction to different modeling techniques. Okay, so you have to aware that this model coming under, regression is coming under which model? So it is coming under the predictive model. So this predictive modeling, what it will do, it will investigate the relationship between two kind of a variable. As already I told you, y is equal to mx plus c. So it will talk about how the relationship between all the variables this side to this side. So this variable is called a target variable. These variables are called independent variable or predictor variable. Okay, so these variables are predictor or independent. This is called a target variable. So there is a significant relationship between the predictor variable and the target variable. Okay, so that way. So this the independent, then the dependent. Always there is significant relationship. How variables are, play a role to get this value, right? So the strength, how the relationship, how correlation between two, that will make an impact on the model. Okay, is having a strong, then I can say that a strong correlation. Sometimes it may be a weak correlation, or sometimes it may be a negative correlation or positive correlation. Spawned upon. So there are various curves. There are various curves are there. For example, you can have a curve like this kind of a curve. You can have a curve like this kind of a curve. Then you can have a curve like this kind of a curve. Then you can have a curve like this kind of a curve. So different kind of curves are there. So these curves we'll talk about. These curves will talk about how which regression model can apply for that, and how relationship between the data. So by the way, the independent variable, when we talk about independent variable, that side mx is plus c, like it is here in mx, x is the only independent variable. Suppose I can have a variable x1 into a plus a into a1 plus bx2 plus cx3 plus e, like I'm here. Y is equal to, the equation is y is equal to a into x1, okay, plus b into x2 plus c into x3 plus error, random error, okay, like error is there. So if you have like this, then here you see this is one variable, this is the coefficient, this is one variable, this is the coefficient, this is one variable, this is the coefficient. 1 minute, 1 minute. Oh, fine. So the number of independent variable, here you see x1, x2, x3, a, b, c are the coefficient, e is the error. So that way, number of independent variable may be single or multiple. Okay, then shape of the regress curve already I told you. Then type of dependent variable, okay, that may be a ratio or it may be a, what kind of dependent variable. It is, sequence or it is a true binary. One or it is one class, multi-class, class of A, class of B, class of C. So the data may be fall on any category. The data may be fall on any category. The data may be fall on y may be 0 or y may be 1 or y may be any value that will fall on particular curve. So that way, there are different way the dependent variable having a data. So that we'll talk about the regression algorithm. So for example, you see the relationship between the dependent and the independent variable. So here I can have a strong relationship. I have a smooth line here, scatter plot with the smooth line here. So this will give a smooth relationship. Here you see, you will have the smooth relationship, weak relationship. This value too much of scattered or generated from the absolute line, AB line. So I can have a scatter plot. I try to have a line, linear line there, linear. But, when we see the disperse of data, disperse of the data over the length. So length, if you calculate, it is very high. So I say that a weak relationship. But the another category 3, you see here, negative correlation. This is a purely positive. This is a negative correlation. So this increase, this decrease, this decrease, this increase. Such kind of a correlation where you have. So here in a weak negative correlation, such a kind of a relationship from the variable we could see in a real-time example. We could see in the real-time example. So what are the different kind of regression, techniques are there? Different kinds of regression techniques are there. The very basic regression technique is a simple linear regression. The very basic regression technique is simple linear regression. The second one is multiple linear regression. The third one is polynomial regression. The fourth one is logistic regression. The fifth one is ridge, then so regression. So going to today, I don't think we are having a time to discuss all that. But what we will see, we will restrict simple linear, multiple linear. Then in the logistic, we can try to see both. Binary, binomial. Okay, so 4 algorithm we will discuss. So what exactly is regression? Actually, you see, these are all the different regression curve. These are the different regression curve. So for this regression curve, you can understand that this curve coming under which model you can use of it. Maybe for example, I can take this one. I can take this one. I can say that this is a simple linear regression. So here I can have a multiple points, then I can say that multiple linear regression. So here that it will keep on increasing at over the time. Over this keep on increasing. So I can say it's polynomial regression. So here you see you can have a what is called a type curve. So at one point I can have all the points are lying in one side, another side, other points are lying in other side. So I can get this is 0 or 1 can say. So logistic regression, the classification I can do from this. Okay, so I can say that what kind of different, based on the curve itself, you could understand. First, I am plotting the curve with the existing data. So once I plot curve, then I could understand that which kind of regression I have to format, which kind of data set will read all the detail. Data set will build all the detail. Okay. So first, let us see that a simple linear regression. What exactly is simple regression? If you have only one independent variable, then I can say that is a simple linear regression. Let me explain. Okay. So for example, here, actually what exactly the graph? If I have a graph here like this, yeah, explanation. Okay, anyway, I'm going to give an explanation. So a simple linear regression where I have a y-axis, then x-axis, right? Then beta naught is the intercept. Then beta 1 is the slope. Okay, the error is the random error. This is the theta. The error is the random error. So in that case, I can go for simple linear regression. Linear relationship between the this independent variable to the dependent variable. The relationship between the independent variable to the dependent variable. So either simple. This is only the difference between multiple linear and the simple linear is in the multiple linear regression. 1 minute. So in multiple linear regression, there are more number of variables. For example, here you see there is a beta naught, beta 1, beta 2, beta k. All these are all the coefficients. Beta naught is slope. But again, if you have a beta 1, beta 2, beta k are the coefficient, x1, x2, k up to xk are the independent variable, and y is the dependent variable. So in this case, I say there are multiple variable in the regression algorithm. So I can say it is a multiple linear regression. That is the only main difference between linear regression and multiple regression. In polynomial regression, how it is a non-linear data set. Non-linear data set. So what then exactly the non-linear data sets? Actually, here you see one point is x. Suppose I say values y is equal to 1, x is equal to 1, then what will be the value? Maybe assume that this is also something 1 like that. Ultimately, if you the constant coefficient x is equal to 1, then I can say x is equal to here 1, y is equal to then if I keep on increasing the value as 2, then it will increase in the double. So ultimately, if you plot the value will plot and it will go like this. Because this is not the x2, it is a x squared. So ultimately, the squared value will be added with this. So maybe x is equal to 1, can say y is equal to 2, here also 1, here also 1. Can say 1 plus 1. 2, then here if s is equal to 2 plus 4, I have to say. X equal to 3, then 3 plus 9 like I have to say. If I plot the value 2 here, 4, 6 here, then 12 like it will keep on growing. So in that case, I can say that the regression model is, which regression model I have to fit? I have to fit the polynomial regression model. Then the another regression model is called logistic regression model. Another regression model, what I can say that logistic regression model. So logistic regression is used to solve the classification problem. So what is called linear regression, multiple linear regression, and the polynomial regression. These are all will talk about how the data go, and it will talk about more on prediction. Okay, talk about more on prediction, how it will look like. Okay, for example, here I wanted to see expense. Okay, how much is salary? How much salary? So based on the experience, I want to give the salary to the already existing many people they are get salary. Okay, so all the points I plotted. Suppose a new person coming with some years of experience. Okay, then how much salary I have to fit? Suppose that person is having that much amount of experience, X amount of experience. So X amount of experience, then Y amount of salary. Y salary I have to give. Okay, X experience, and I have to give the Y salary. So this is the point, this point, this point, this one. So I have to predict that this is the line. So I will give the salary. So someone is coming with the own experience, then I will plot the line here. So wherever it is me, then that Y1 salary I give. Such a way I want to standardize. So that is what is called linear model. But once I polynomial, it will go with other kind of way. But it again, it will give the value like this. But once I go to logistic regression, the logistic regression, mainly used to solve the classification problem. So in the classification problem, there are different ways you can have a classification problem. For example, you can have a classification as binary classification. Then you can have a classification as what is called multinomial classification. I mean, more than one category. Then you can have a classification as an ordinal classification. There are different classifications are there. So that way, if you wanted to work on multi-class, ordinal class, then you can go to logistic regression. But logistic regression, you can have an equation like a sigmoid equation. Okay, but again, we are bringing from the regression equation only. We are bringing this equation. Actually, what exactly is sigmoid equation? Here, if you 1 divided by 1 plus epsilon. I mean, E means Euler minus Z. If I give any value, to this equation, right? What exactly that will be? 1 divided by any value. 1 means then it is equal to it will give 1. Then if it is having any value, then definitely the denominator is higher than the denominator. By the way, it will be 0.9 or 0.8 or 0.7 or 0.4 like that. So all this value will be 0 to 1. Always the value will be 0 to 1. Whatever the value I substitute here, I will get value from 0 to 1. So I wanted to make a classification whether 0 or 1 or whatever the way, multi-class or multinomial, multi-class or multinomial or ordinal. That way it will give the classification problem in the logistic regression. Let me explain the first simple linear regression. 1 minute. Before that, I will take a printout of that. I will stop share. Okay. Actually, I will. Actually, this will be an interesting problems you wanted to work on the regression model. I will take a printout. Okay, I will see this. I think my screen is visible to you. Yes. Now we are going to discuss very simple problem, right? In the simple linear regression, here you see I can have a graph like this. This is X, this is Y, and to take that the linear graph I can have in a different manner. The linear graph I can have in a different manner. For example, one case I'm taking. Normally someone is joining in an institution, they may not get the salary of 0. Or in some cases, in some use cases, it will start with the 0 and it will keep on go. But the salary and the experience, it will not go, from the 0 value. So maybe I will start from here. So initially, a person with the 0 year experience, the person start with the 10K or 15K or 20K like that. So in that case, what will happen? So here, assume that it's a 10K, then this is a 0. Then it go 1, 2, 3, 4 like this. Okay, for this. So in this, you see this is called the beta naught. So where exactly the curve intercept in the axis? Where exactly the curve intercept in the y-axis? That is called the beta naught. Okay, beta naught. Then what exactly the beta 1 is? Actually, each curve has its own slope. Each curve has its own slope. Each curve has its own slope. So its slope where so this slope is different for each kind of a use cases. It can't be always same. Can be always same. So in that case, that slope is what is called that. It is called beta 1. This slope. This is theta angle. How much angle? Because this angle, maybe another curve, maybe like this. That slope is something different. Okay, this theta 1. So there is a difference between theta 1 and theta 2. The difference between theta 1 and theta 2. So that way, what is called that will be different for each data. That will be different for each data. So the beta 1. Then the x is the value. Okay, x value. So slope here. That then epsilon is the error. Beta 1 and are the coefficient. Okay. So normally what we have to do, we are doing is we are using the least square method in mathematically to find out. If I give a certain value for this equation, if I give a certain value for this equation, right? How to find the best fit? I have a value like this. Assume that I think participants will able to see that. Is it possible to view the, suppose if I have this kind of dots, then which is the line? Whether I have to draw line here, or I have to draw the line here, or I have to draw the line here. Which line has to best line? So I have to find best line. So how to find the best line for that? So there is a least square method. So what I have to do, it is to find out the mean and actually plot y and y dot pass. Then point with the mean, I will find the difference from the line to this point and how it is this from this point. All the value I'm going to calculate. Once I find the value, then I will be able to find the best line in this in the graph. Okay, so maybe if you go to least square method, then you can understand that it's a pure mathematical, simple mathematical equation to find out the least square method. So using the least square mathematical, you can see the one, but at the same time, one minute. Okay. Okay, so I want to find the best fit for the line. So number of iteration, how many iteration I will do. So finally, I wanted to get the best iteration. Finally, I want to get the best iteration. Now I will tell you what are the steps, and we will see how to flow with that. Actually, normally whenever you are talking about the regression algorithm, fundamental ideas, first we have to collect the data. First we have to collect the data. Once you collected the data, then you have to pre-process the data. What is a pre-processing? You wanted to see that how values are probably there, or you wanted to remove some values, or it's a duplicate rows. So all the things wanted to. So once you wanted to see all the thing, then that is what's called how I can pre-process data, transformation and pre-process the data. We used to say transformation and pre-process data. Then predict the result, or I can say that fitting the regression. Okay, fitting the regression model. Then predict the result. Then once I the model, then I can say how it is accuracy or precision, how it is precision, and I will see the accuracy of the predicted model through some the confusion matrix. Finally, I visualize the result. These are all the best procedure, but we have to follow for the regression model. So again, first we have to collect the data. Second, we have to do the pre-processing. So pre-processing is nothing but doing the null values and seeing the outliers, remove the seeing the duplicate values and remove the duplicates, like I am doing. Then fit the logistic regression, actually logistic regression or linear regression, whichever the regression you want to see that one. Actually, I want to put that one in the logistic regression. Okay, fine. But is any other kind of a regression what you want? That regression you have to fit and predict the test result. So once you put the test result, then you have to see your test result is accurate, 100% accurate or 80% accuracy. What is the precision? All the thing you wanted to see. That way you will have a confusion match. Finally, you can visualize the set. Okay, so let me explain how we can do that program. How we can do that program of logistic regression. We can do that program of logistic regression. Actually, the generic steps is get data. As already I told you, put the linear regression model, fit the model, then pick the output. So that is what we are going to see now. That is what we are going to file. And actually, I am using the Visual Studio Code for this. Visual Studio Code for this. No thanks. Okay. So just normally I will simply see, once you understand this program, then all programs are very good. So what I am going to do, I am going to work for the salary data. Salary. So data. So what exactly a salary data is? So if you go to Python data set, salary data. So this is a salary data. So in the salary data, I can year of experience. Based on year of experience, I can have some salary. So here I have almost 30 observations. 30 observations. So for the 30 observations, I'm going to bring the prediction. Okay, that is what I'm going to do that one. So year of experience is the one column. Salary is the second column. How the relationship between year of experience and salary over that data. So the data, I'm going to train a particular model. Finally, I'm going to predict the value. That is what I am going to do. So the data prediction. So that is what we are doing. So already I told you that equation is y is equal to b0 plus b1x plus error. Okay, that is what your thing. So here what is called, maybe I can, what is, sorry, this is the comment line. This is the comment line. Okay, now importing the library. Normally what is happening, mainly we are going to read. First thing is read the data, so import pandas is the library to read, to work with the data frame as PD. Okay, then I am going to read the data like how my data salary underscore data is equal to PD dot read underscore, so shift enter, read underscore CSV, right? So I have a data as a salary. What is the name? Salary data dot CSV. Salary underscore data dot CSV. Right now, if I have to put this one, then yeah, already I put the PD. Yes, fine. Then I to enter file not found error. Actually, file not found error I'm getting. So since I have a file not found error, what the problem is? I have to say that OS import what I can say OS dot import OS. Okay, OS dot set working directory. Okay, you can set the working directory. First, I will get correct working directory. Print the end. So that working directory is this one. This is the reason my data set is available. Then you can put that d:/python/ data set like you provide the thing, or you can set that os dot set working directory. Set working directory WD. Okay, like you can also set that to the directory. Then automatically you can provide only the particular set the file name if you are providing that itself enough. So that way you can provide. So once I read the data, then second thing is I wanted to see how the data is. So what I can say that what are columns are there? List salary data dot columns. Okay, so once I put like that, the data not defined, then I am doing this for, then I put the column. So what are the columns? There are two columns, years and salary. Okay, years and year of experience and salary. I think you'll be able to see here years and number of years of experience. Salary and years of experience. Then I wanted to, you can get the type everything. For example, you wanted to see that salary data, what are some the salary data dot head data. So few data like years of experience, salary, and the shape, everything, what number of column, number of row, everything you can get it from here. I wanted to plot the scatter plot. Okay, so for plotting, I'm using that matplotlib. Import matplotlib dot pyplot as pt I'm giving. Okay, so I want to import the matplotlib. Once I put the matplotlib, then to plot the data existing data. So plt dot scatter plot I will put. Okay, scatter is equal to x is equal to salary data of years of what is called I copy this. Years of experience, comma y is equal to data of within double quotes salary. Okay, so if I run this, then what is there? Then plt dot show. Okay, now you see almost if you see the value, that is year of experience and as well as the salary, almost it is linear. But exactly you wanted to put the linear curve. Exactly you wanted to put the linear curve. Exactly you wanted to put the linear. Suppose you wanted to put the absolute line for that, then what I can do? PLT. So this is what first the analysis what you have to do. So what plot I'm going to do? Maybe I wanted to put the plot with the smooth, scatter smooth ridge plot I can do. So I can say that import cborn. That will not work with this matplotlib. Cborn as SNS like I am doing. So SNS dot I can say ridge plot. SNS dot ridge plot. The same x is equal to salary data. y is equal to, sorry, year of experience. Okay, both data I am providing, Then what I wanted to is a line I wanted to draw. So line for KWS is equal to, here I am giving that color colon red, or then comma line width colon, I will say 1. Okay, so this is the value I am giving. So now I scored name is not defined. Okay, first I have to run this one, then I can say that this line. Okay, now I am going to have it. Now I can say PAT.show. Okay, so if almost I am getting the line, that is absolutely what I wanted to draw the curve. But I want whether it's a best fit or not, that I not know. So this is normal. I am putting the best what I am doing. So I want to bring the best line from this. Okay, what I wanted to do, I wanted to take the data for training as well as for the testing. I want to take for the training and for the testing. Now I take the data which is excluding the what is called the column data set having a copy of only all without the resultant column, So x is equal to salary data. Dot ILOC. ILOC is location. I mean index based data. So index based data. I wanted to have the data, all the rows and all the column except one column, minus one column. Okay. So dot values. Okay. So excluding the last column. Last column is which column? Last column is the salary column. There are two columns. If it is having a multiple column, I wanted to bring the relationship between only two columns, then it's good. But definitely it will get the value of, remove the value of last column. So excluding the last column, what is the data that is to store into the X? It has to store into the X. Okay. Now I have that value. So print of X, then you can see. So this is the year of experience. Okay, the year of experience. Then I wanted to have a data set which is consisting of salary. So y is equal to salary under data and ILOC of all the rows, first column dot values. Okay, so this is what the values to get a copy of the data X to the last column. So this is the copy which I got it from here. So colon, sorry. So earlier we got the data, now I get the values of that value. Okay, so this is the for that. Now print of. Okay, so I get that y value. This is the salary value for that. Now I am going to do splitting the data set into two sets. So for splitting the data set, I can have a sklearn from sklearn dot model selection. Okay, import train test split. So this is the library which we are going to use for splitting of the data set to train and test. So what I want to do, x train, x test. Okay, x train, x test, y train, underscore. So four thing I am classifying train for data for that training. This is train. X train and y is for training. X test, y test for testing the data. Okay, X test and y test for testing the data. I can going to do that one. So for the transcript set, what is the data x comma y? I am passing the data x comma y, and what is the size of this say? Size is test for size. Size is equal. So 20% or 30%. So 0.03. Okay, that I am doing. So the test is train. Test train not different. Okay, I run this previous line. Then I am running the. Okay, now it is over. Now what I am going to do? I am going to do the random, normal, the value should be normalized. Okay. So whenever you wanted to put the in regression, particularly when we go for linear and multiple, singular, multiple, you have to normalize the data, So using this standard method. Okay. So from sklearn, right? Pre-process. This is the pre-processing data. Import standard scalar. Okay. So I'm doing standard scalar data with standard scalar. Okay. Now I am going to extrain equal to is underscore x. This is a standardization of a value dot fit into fit underscore transform x underscore trying. Okay, that is what I am doing. So pre-processing, then scalar normalizing value, that x prime value I am normalizing, then x text value also I am normalizing. X underscore test is equal to c underscore fit, right? C underscore fit. What is the value? SC underscore x. C underscore x dot fit of underscore. Okay, this also I am doing. This also I am doing. So once I put this value, then I'm going to fit the simple linear regression. Simple linear regression. Next, I'm going to fit the simple linear regression. For doing the simple regression, sklearn, this is the linear, already available. Linear model is available. Import here. Linear regression. Okay, this is very simple, but understanding the thing is very much important, because the least square, if you do, then you can understand that how it is disposed and how we're going to get value. So now what I'm going to do, I want the regressor. So regressor is equal to linear regression. Linear regression. Okay, so I am creating the this model. Then regression dot score regressor dot score regressor dot score. So I prepared, I am sending the x text y underscore test. So I will see that how this model give for data. Okay, for regressor is not defined. So linear regression is not declared. Okay, fine. Now regressor. So almost what it is saying, that linear regression instance is not fitted. Call fit with the appropriate argument using the estimate. Okay, so we have to regressor model will not fit into the value, or will not be able to get. We are seeing that value only. Train dot split size, right? Then we are scaling the value. So after scaling the value, what we are going to do? We are going to do the linear regression model, but let it be the extrain and train to this. Okay, so instead of finding the score, linear regression instance is not fitted yet. Okay, call fit method. Okay, fit method we will do. Fit method we will do. So after doing fit method, then we will find out how we can get value. How we get the value. Now what I am going to do, I am going to put the regressor fit. Regressor dot fit. Regressor dot fit. Regressor dot fit. X underscore train, comma, y underscore train. Okay, now regression formed. Now I am bringing this regressor score. I'm bringing the regressor. Maybe otherwise I have to pass the value. So almost you see here, the regressor score after fitting that, you will get 93%. Okay, so almost 70 I am getting. So this salary and year of experience, I will get almost 93% accuracy. I mean, I will get a score. 93% score I will get. Okay. So this score will give, after fitting that value, how it will do that. Now I am going to prepare predict the test result. Okay, predicting the test result. One minute. So now I am going to predict that model y underscore predict. Okay, y underscore predict. Then what my regressor? I have a regressor. Okay, regressor dot predict. Okay, predict. So I wanted to predict for how many years? I wanted to predict for 5 years. Okay, I wanted to predict for 5 years. You see that how value will be. Shift enter. Print y underscore pred. So what is the value? 214141. 214141. Okay. Let me go there. 5 years. Oh no! It is not fitting properly. Okay. First I fit it. Then I will regressor dot predict. Then I predict the value 2141. But accuracy, I am getting that something different value. Okay, why predicting is giving some value? What is the value for 5 years? 5 years means I am getting that value almost 66,000. 6,000 salary. So now I run the whole program. Maybe I will get it properly. 5 save. I save sample underscore linear. Okay. So now running this code. Okay, I get this. Then I can get this. Yeah, I will get different values existed with the 0 code. So this is the final value I will get it for this prediction value. Okay. So this prediction value I'm getting like this prediction value. So I wanted to prepare, the data. Whatever the data you wanted to prepare, you can prepare for it. All the data you wanted to prepare, you can prepare for that. For example, but here almost I'm getting that regression fit is X train, Y train, but it is giving 1,89,814. Okay, 1,81,814 it is giving. But again, when I predict, it is giving some other value. Okay, it's predicting some other value. Okay. Right. Yeah, I take another program where I will take linear, where I take run the code. The code Y predictor. Yes, participant. Yes, please. Yes, please. So this shape, then year of experience. This and all we need not to go. So this is the X value. This is the Y value. Then scalar Y dot test. Then I'm not doing standard scalar. Directly I'm going to import regression. I will do that one. Okay, to the value. Then I wanted to find The prediction, yeah, 73,000. How much I am having that? So 5 years. 5 years I can have almost 5 years 66,000. 4.9 years I can have a 67,000. 5.3 years I can have a 83,000. So almost what is happening here is I am getting the salary for 5 years is what is called 73,000 rupees. So 73,000 rupees is the value based on 90% accuracy. Okay, once I have a 93% accuracy on score, okay, go with the 93% of accuracy of the score. Sorry, 97% accuracy of the score. Then I will have a Y prediction. Then I print the Y 73,578. Almost it is exactly say exact value for 5 years. But 5.1 is having 66. But 4.9 is having 67. But 5.3 is having 83. Doing normalizing that value, then I am getting the prediction value. Now I am going to get for all X text. I'm going to predict for all text. Okay. So you see for all X text, say that X text. Okay. Print X underscore text. Okay. Print X underscore text. This is the X text. So the experience. Okay. For 1.5, 4.1, 3.9, 9.5. So for that, my predicted value. For that, this is my predicted value. For example, 5.8 is giving 77. 4 is giving what is called 64. There are 9.6, it is giving 1,16,035. So like it is giving that value for the testing value, testing that value, right? Now I am going to visualize the, visualizing the value. So visualization I wanted to provide. Now I am going to plot the value. So first of all, when I plot the value, so here I say that the PLT I am visualizing with the training data. So I am going to plot for training as well as for testing. So this is my plot for training data for salary and the experience, salary and experience. So once I see that thing, this is the plot already we have discussed. This is the plot already we have seen. But we have seen the overall plot of the whole data. But this is the plot of the only data. This is the plot of the only training. So training data, this is the what is called regression line. It will go. If I go with the testing data, so I have a testing data, and any new data if you provide, then the testing data will give a plot in a way like this. So ultimately, what is happening? I have my plot. That almost 91% fixing with this one. Okay, so that is what the score also it is giving. And when we see the train data plot, text data plot, if you put the curve, the angle and the intercept, everything, if you put the summary of the things, then you will see almost it will what is called give the accuracy. So that way, what you can fix this what is called a sales salary with the experience, you can have a linear. Sales with the experience, you can have a linear. Then second one is we will go for the multiple linear regression. So as already I told you, multiple linear regression is you are having more than one value. Multiple linear regression is you are having more than one value. So more than one value here, x1, x2, xk, all the things are there. So beta 1, beta are the regression coefficient. Beta naught is the what is called the slope. Okay, beta naught is the slope. So what are the assumptions we go for multiple regression is very fundamental assumption is there is a linear relationship. Whenever I wanted to find the relationship between the independent variable, maybe the variable may be x1, then one graph, and another graph x2, okay, then this is y, this is again a y, then this is also y, again this is x3, okay. So I wanted to have a linear relationship between one, x2, I'm sorry, not between x1 and y, and x2 and y, x3 and y. So that is the fundamental assumption. Second assumption is the independent variables are not highly correlated with each other, okay. So what is the meaning is multicollinearity. What is collinearity? Multicollinearity means if x1 and x2 are too much correlated, then there is no need for working with two. I can completely ignore one column. So this is the reason what I can say that multicollinearity should not be there. Data should not have a multicollinearity. So the independent variable are not having highly correlated with each other. Then the residuals, okay, that should be constant. Then only, the variance of the residual should be constant, because residual should be constant. Then multivariate occurs when residuals are normally distributed. So these are all the assumptions. So with this assumption, we are going for multiple linear regression. We are going for multiple linear regression. So in the multiple linear regression, I have the same, but here I can have advertisement data set. So advertisement CV, what I have it, I will show the data set. I will show the data set, advertisement data set. Yeah, advertisement data set. So once I have advertisement data set, you see, I am doing the advertisement with the TV. Then I am doing the advertisement with the radio, doing the advertisement with the newspaper. Okay, 3 way I am doing the advertisement and how this. I wanted to find out which advertisement is more, useful to increase the sales. Which advertisement is not that much weekly or medium. Such thing, all I can get it. But I wanted to know if I wanted to increase the sales, what I have to do on TV, or whether I have to increase advertisement on TV. TV is not that much necessary, or I wanted to increase advertisement in radio. So that kind of a data prediction I wanted to do. Which advertisement will give more impact on sales? That regression I wanted to draw. Okay, so any value if I give, that the sales will increase. Suppose if I spend $150 and $24, $4 newspaper, this much I am spending, how much my sales? Okay, so that way I am going to pick with the multiple. So here all TV, radio, newspaper. So one is a what is called, that is a presentation. No, yeah, resume. So here you see I can have a sales with how the relationship with the TV. Then I have a sales relationship with the radio. Then I have a sales relationship with the newspaper. So how the relationship, and if I want to spend some amount, X amount in TV, X amount in TV, X2 amount in what is called radio, then X3 amount in the newspaper. So what is the impact of the sales that I want to find? So here X, X2, X3, all the variables are playing the role. So that is the way, since this is called multiple linear regression, So as we have discussed in the earlier programs, again the same way, the preparation of the data, then processing of the data, then finally we are to prepare the model, fit the model, and predict the test result, and visualization. That is what we are going to do. So let me explain the program. Actually, I prepared the program for you. Just I will explain the program. So you are all aware, when you wanted to prepare the data, you need the pandas. Okay. Then for plotting, you can have a matplotlib and a Sequan. Okay. That is what you need to have. Okay. NumPy to do some small mathematical statistical operations. Now I am going to read the data. So read the data from Deacon Python data adjustment.tsv. Then I am reading the data. So once I read the data, you see the head of the data, that is TV. I mean, first 5 columns. Okay, radio, newspaper, sales. Then what is the shape? Number of columns and the number of rows. There are 200 rows and 4 columns. There are 200 rows and 4 columns are there in the data. There are 200 rows and 4. So including header, 1 rows are there. Okay. Then now I wanted to check the missing value. Missing value, if you check, if missing value, that value you have to remove. Data set dot is NA dot sum value. Okay, data set I can check. So what is my data set? So I have a data set is NA value. Is NA value I have to check. So NA value, total number of missing value. So once I see the missing value, then missing value for TV is equal to 0. Missing value for radio is equal to 0. Missing value for newspaper is equal to 0. Missing value for sales. All the things are become 0. Now I wanted to check the outliers. Now I wanted to check the outliers or any duplicate values are there. So duplicate value you can check with the data set dot data duplicated, because any row duplicated are there. Data set dot duplicated of any. Okay. So you see that false. So no value in data set is duplicate. Suppose this entire record duplicate again, then it will say that there will be that the duplicate will be true. Then we can find out which row duplicate, that we can, all the rows we can remove, that also we can do. So checking the duplicate rows, we have to do, that is data set duplicate. So it is false. Then now I wanted to see the outliers. Normally whenever you wanted to see the outliers, okay, whenever you wanted to see the outliers of a data, then the ultimate thing is we have to use the box plot. Okay, so box plot will give the the median, and what are the values, these are the outliers in the lower side, these are the outliers in the upper side. That outliers I want to see here. So box plot I can draw. Box plot I can draw. So from the box I can see if any out, because outlier will always impact the model. Outliers will always impact the model. So I can set 5,5 as a row size. I can take. Then PLT1 is for T. Okay, subplot PLT1 box plot for TV. Then plot number 2 is for T2 it for what is called for newspaper. And PLT3 for what is called radio. So here I am passing x-axis for each, and the axis is equal to 0, 1, 2. Finally, put the type layout. Then TLT.show. So the shows that in fact TV exactly median is there, but in the newspaper there are some outliers are there. Newspaper you see there are some outliers, but exactly it is fixing like a thing. But the radio starting from 10 to this much we are spending. TV we are spending almost 75 to 220, but the newspaper we are spending 15 to 42 likes. We are doing that. That is the fact. So for few cases it is going up to more than 100. Okay, so those things maybe a data or outlier data. So that I found. Okay, so once I found this, then how distribution of the target variable, So now see the distribution, how it is distributed in this scatter plot. Whether normally already I told you, whenever wanted to go for the linear equation, you have to check whether the distribution is a normal distribution or not. If it's a normal distribution, then definitely we will have a what is called, your plot will be your model more accurate. So distribution I wanted to do the dist plot. So with the sales, okay, with the sales, then PL.show, I can have almost the normal distribution, Then I can proceed with the what is called the multilinear regression. Okay, so now I wanted to see how the sales is related to the other variable. Sales is related to the TV, sales related to the radio, sales related to the newspaper. Using the pair plot I can use. Okay, so pair plot will give the relationship how the sales impacted with the variables. So sales with the variable that I can do. Okay, so now you see actually TV is, if you see that how it is impacting on the sales is more what is called ultimately it is a linear. But here you see the correlation between the sales and TVs almost I can say 0.9. Because normally the correlation is what is -1 to 1. -1 negative correlation, 1 is positive correlation, 0 no correlation. Almost here I can have a what is called a point, very weak. Here also very weak correlation. But when TV is having the whatever the amount I am spending on the TV is directly impact on the sales. But I cannot say that one for radio as well as for the newspaper. But somehow it is also not. There is a dot here, So that is it. But you see there is no dot here. So again I can say there is some impact. So I have to see which in more impact and how I can get that things. Okay, so this is the pair data, pair graph, which will give the relationship between TV, radio, newspaper with the sales. Okay, with the sales. Once I find, I can see the heat map. The heat map will give the annotation. The heat map will give the annotation between the variables, So heat map, I can annotation. I will bring it. Then you can see the graph. You see TV is having 0.9 in the sales. This is the regression. Almost TV is having more impact on the sales. Radio is having only 0.35. Newspaper is having 0.16 only. So this diagonal data we need to take, right? So TV is having more on sales. TV is having more sales, radios, like we can. So this is highly This is 0.02. So 0.02, I'll move 0.16, then 0.35. So that is what we have seen from the paragraph also. Radio is okay, but in newspaper, it's not that having the correlation. I'm spending the money on the newspaper, but it is not impact on the correlation. That you can get it from the what is called the heat map. Now, what I'm going to do, I'm going to, since I do the explanatory analysis, I'm going to see the how prepare the model for training as well as for the testing. So I have to import the S1 data set for split the data, train and test. Okay. So data set is X is equal to TV, radio, newspaper. Because here you see, I want to remove sales. So X is this data. Y is only sales data. Then I'm taking this model, and this model, then linear regression model also I'm going to bring. It's all the three library. Now I'm going to split the data set as a test and train. So here X test train I'm going to do X and X comma Y I'm passing here. Then 30% for test random state I'm using for seed. Okay, random seed for setting the seed for random I'm setting that. So once I do that one, then I'm going to prepare the training data, testing data, X train, X then Y test. Now I'm preparing the model. Okay, model linear regression. Then I'm going to fit that one. Then you can also see score. You can also get the score of this model. You know the score of this model. So score of model will give what is the score for the particular thing. So here MLR is one. Suppose I say MLR dot score of X underscore test comma Y underscore test. Okay, that I am giving. So the score is 6%. Okay, because you see, if I have only TV alone, then I will get the 95%, more than 95 I will get it. Since the model will also play the role on with the no correlation in the newspaper. So maybe that may be reason where I got only 86. That may be the reason. So I'll model the what is called the coefficient. Okay, model the coefficient. So where exactly the intercept is. So intercept is 4.34. Now I'm going to bring the value. So what exactly that equation is? Beta naught plus beta 1 plus beta naught. Beta naught is how much? 4.13. Intercept. This is the intercept value. So this is the intercept value plus what is the equation? This is the equation. I actually participate. We unable to discuss with each one. So beta naught. Then beta 1 into x1. Beta 1 is into x1. Okay. Beta 1 into x1. So I am taking the first value. So the coefficients I am going to take. The coefficient I take. So in the coefficient for TV is this much, and the radio is this much, and the newspaper is this much. This much into this much into, maybe I will take the value, first value. Okay, first value of this advertisement. Or I can say into TV value plus, okay, then beta 1 how much? I mean, this is the radio coefficient. So this much star, what is the radio? Okay, plus then this much. Actually, you can go with the 2 decimal point star newspaper. So this is the overall thing. This is the overall. So intercept value is value. If I ignore this, if you ignore radio and newspaper, then this is the sales outcome. So sales is equal to 4.35 intercept value. Then each TV value, each radio value. For each row, I am going to pass and the sales will. Right. This is the model, coefficients arrived through the linear regression model. Okay. So now once you have a equation, then actually I have shown, so 5.8. So actually complete I am bringing. So you can say that what is called the 5.38 into TV. Okay. So maybe here you can 4.33. Then data. Then radio. Okay. Data. Then in fact 0.0062 into newspaper. So I think you'll be able to find out exactly what is the equation, multilinear equation. Okay. Then what do predicting the text and test result. So this is model, and I'm predicting the train and test result. With this, it will give for test result. It will give for the test result. Okay. So it will give the test result. So actual value, for example, actual predicted value I can show to you, right? I can display. So here you see. Here you see, maybe I will show to you. Again, I'm running the code. See, 18 is the actual value. My predicted value is 20. 10 point almost exactly. 7.66. Then what is called 16.6 is 17. So almost my predicted value is very near to the, because this is percent I can have. Here again 16.16, 18, 8, 10, here 11. So this is what I am getting for a particular test data set with the actual value and the predicted value. For example, if I go with the value TV 56, then radio is 55, 67 is my newspaper, then what will be the predicting value? It will give sales is 30%. Okay, 13 point something it will give. Okay, so you can change the value. You can. This is a predicted value. But anyhow, we will see the R squared coefficient for determination. How it will go with one. So first mean error. Mean error I will give you. So this will printing mean error. Print. So this group. So almost exactly it is nearest to 1. So absolute error. Actually, there are different values are there. R squared model. So this R squared value, if you print, then this R squared value is almost, if I print that value, it is giving 90.11. Okay, 90.11 is giving the indicate that they are fit into the regression model. So almost it is regression model. Then if I go with the mean absolute error, it should be nearest to 0. Okay, close to 0, it is good. Again, for when I have a mean square error, again it should be nearest to 0. Okay, so to 0. So if I print, then I will get the print mean square error. So this will be almost 2.36. So it is not too much. Okay. Then standard deviation for that. Again, I am the print the root of mean square error. Okay. So I think it will be close. Okay, 162. So I am putting all these three: mean absolute error and mean square error. Then you can say that square error is almost giving the value very near to 0. So my predicted model is it's a right it's appropriate model to predict the multiple linear regression. Okay, multiple. So how much I can spend? So I can have idea about how to spend for radio, how I have to spend for. So now based on that, I can see the curve and the value. I have to spend more on TV. Okay, that will give a more impact, more correlation. Okay, so newspaper and the radio. Radio is some impact, and newspaper is also not having that much impact. But spending the money again is a meaningful. Okay, that is what it shows. Okay, linear regression. Then next one is logistic. If I go to logistic regression, it is three things are in the logistic regression. One is binary classification. It's purely a classification based model. So maybe the higher level model we can have like maybe classification, like the models are there. But this is the fundamental classification algorithm for fundamental classification algorithm. Fundamental classification using the regression. 1 minute. Okay, so now the curve, regression curve is equal to y is equal to f of x. So this f of x is what we say that 1 divided by 1 plus is called what is called, we say that e power minus is it, e power minus. This is what we have given, sigmoid function. So the y is equal to f of x is if it is fixed. So here any independent variable, y is the dependent variable. So normally, the basic regression will give 1 or 0, yes or no, true or false. But what are the assumption for logistic regression? Again, the dependent variable must be categorical value. But in the earlier, for multilinear equation, dependent variable is not the categorical value, it is a continuous value. Okay, it is the continuous value. Here it is a categorical value. Again, here that independent variable should not have a multicollinearity. What is the meaning? The independent variable should not have a high correlation with the other independent variable. So that is the way we have to see the multicollinearity. Then you see, actually I wanted to the logistic regression from the regression. This is the regression curve. This is the regression curve. So in the regression curve, if you see, this is one. So how I have to make that? No, I have to bring this from 1 to 3. Actually, here I wanted to make this as and this as not infinite. I have to make not infinite. All things here as 0. So here also all the things to 0. All the things 0. So I am bringing that curve. How I am going to bring that curve? You are all aware that this is the function already I told. This is the function already I told you. Then by from already I told you that the value is always between 0 to 1. How it is between to 1? So always you see, if I put this value as a 0, then minimum, normal is 1 by 1 is equal to 1. If it is having any value, then denominator is very high. So 1 by some high value, 1.2 or something, then 0.98 like it comes. Suppose this value is very high, then ultimately 0.1 like. So always the values become whatever the value, then it will start from 0, it will go up to 1 and go up 1. That range. That is the reason I can think that whether this are 0 or 1. Okay, that can I can bring it. So let me prepare logic function. Let me put the logic function. So the logic function says y is equal to c plus beta 1 x1 or beta not, I can say beta 2 x2 like I am giving. So here I wanted to bring that value large function of y divided by 1 minus y. Okay, that I wanted to get the value from 0 to 1. That I wanted to get the value from 0 to 1. So here, when I have a value of 0, if I assign the value of y is equal to 0, okay, then 1 minus y, one side is infinite, one side it's become 1. Okay, if I put this, I'm taking this and I'm putting y is equal to 1 minus y. Then if I pass 0 for that, then that value is to infinite. Okay, so range y is from, we need range y is from minus infinite to plus infinite. For that, I am going to bring 0. So now what is called 1 divided by 1 minus y. This log I am taking exponential of this value. Then I am making that y is equal to 1 minus y into this value. Then I am multiplying 1 to this and 1 to this. Then I can get y is equal to, for beta naught is 1 plus. This is what I say, 1 divided by 1 plus value sigma function. Okay, this is what I am getting. So here beta naught is a constant coefficient, beta 1, beta 2, beta 3, whatever it may be, they are all coefficient of x1, x2, xn. And Euler number is 2.7. Okay, Euler number is 2.7. Then P of y equal to probability. Already I told you, these are all the probabilistic model. These are all not deterministic model. These are all the model of probabilistic model. So here I can get the categorical output of this. Then type of logistic regression, if you see the type of logistic regression, there are 3 types. Okay, the type of logistic regression, there are 3 types. One is actually one is binomial, the another one is called multinomial, the other one is called ordinal. Participants, shall we have a small break, then we'll continue, maybe continuously answer to you. Participants, maybe coordinators, can you tell me, shall we have a small 5 minutes break? Actually 12:15, 12:20, shall we start?
Yes, sir.
Yes,
Okay,
anybody?
Sir. Yes, sir, we
Five,
take
just
a small
we can have a 5 minutes, because continuously we are from 10:45 onwards.
Yes,
Okay.
sir. Yes, yes, sir. So we can take a
5 minutes break. Just
okay,
a
sir.
commercial break we can have, like
Okay.
serial we can have investment for 5 minutes or 2 minutes, like a commercial break.
Okay, participants, we can have a 5-minute break and we can join at 12:30.
Okay, participant, if you have any question, kindly type into the called in chat box that I could answer your questions. Okay, fine. Okay, let me go to the logistic regression. Let me go to the logistic. Yeah, dear participant, chat box is active. Yeah, fine. Thank you so much. Thank you so much. Participant, sir, what way the regression model is different from correlation? No, actually, yeah, correlation is, I wanted to bring between the variable. Mathematically, we are working with the 2 variable where we are finding the regression. But you want to do the prediction. Correlation will give only the value of value correlated with another value. But what will happen? The prediction model will give the predict for the any other new data. Okay, new data. Correlation is you wanted to represent the data between, or you wanted to see the, that is a statistical analysis. Correlation is purely a statistical analysis. But you wanted to predict analysis you wanted to do, then how for this data, how will be? Okay, so such prediction, sometimes the curve, that is what we have seen in the different curve. So that way, we cannot predict with that one. So that is what is called predictive modeling we will do. Okay, then sir, shall do this for machine learning? Yeah, this is the machine learning only. Actually, what we have seen is it's a machine learning only. It's a machine learning algorithm. Yeah, the regression is a machine learning algorithm. And second thing is, what ID is suitable for machine learning algorithm? It depends upon the programming language what you do. Okay, so for example, if you go for R, then R Commander, then R Studio. Okay, both are good for this, R Commander and R Studio. If you go for Python, then Visual Studio, Microsoft Visual Studio is the right one. As well as you can have a Jupyter notebook. As well as you can have a Jupyter notebook, which will be useful for that. Okay, which will be useful for that. Then next one is outlier. Outlier is data which is not within the boundary. Sometimes we can say that unbelievable data, those data are called outlier data. Unbelievable data, which is called outlier. So those data we have to remove that. Okay, then only our model will be perfect model. Then only our model will be a perfect model. Okay. Outlier is the data which is not within the prey of expected value. Unexpected value. We can say that is a unexpected value. Okay, Colab. Yes, Colab also you can. Python. If you wanted to work only with the Python, Colab. But machine learning algorithm, once you wanted to do, okay, then you can go with different kind of editor, whichever there are n number of editors are there. But what are the editors so popular? Jupyter and Visual Studio popular editor. Because Visual Studio where you can use it. See, always we have to see that it's not only to one programming language. We have to see for different programming language. Once you go for one programming language, then ultimately you have to understand. I have to use one editor for C++ or for Java or all the things. Then I select that Visual Studio is the right editor that I can say. R Studio again, it will be multiple, but R is more powerful for R Studio. R command like fine. I hope these are all the scores, right? Other question? Any other question? So is the what is the use of add constant method? Add constant method in the state model, sir. I get it. I didn't get you, madam, for clear question. I didn't know have clarity in your question. Please give a clarity in your question so that I will give you the answer. Okay, I think statistics model we're talking. Which machine learning algorithm is most useful for finding the accuracy? Actually, it is a classification algorithm, whether the person is having the lung cancer. Classification algorithm. So once you go for the classification algorithm, there are different classification algorithms are there. Okay, Navy base, then even this logistic regression. Okay, classification algorithm. Class SVM. What are the classification algorithm you are going to use with the data set? It will be, that is the reason always people will compare or hybrid it will go. Now many people working with the CNN algorithm, convolutional neural network algorithm. So that way we can have a different algorithms are there for that. What is the ending times? Vaishali Shahu, ending time, I don't know, maybe the minute. I will finish it another 15 to 20 minutes. Okay. So different question. Feedback link. Okay, that you can put it. Fine. So now, since the participants started to ask the ending time, let me quick with the one logistic regression. Okay. That is only the binary logistic regression. So by logistic regression, again the same procedure what we have to follow. Let me go with the simple logistic one. Okay. Here I wanted to have data like diabetic data. I want to so whether the data has lung cancer or what maybe. Here I am taking the diabetic data. So diabetic data set is available in my diabetic data set is available in the. So here there you can have a different column like a pregnancy, glucose, then blood pressure. Yeah, let me share my screen so that you can see that. So pregnancy, glucose, blood pressure, then skin thickness, insulin, EMI, diabetic, then index, okay, pedigree, then age. Finally, you can have outcome. Outcome is whether it's 1 means diabetic, then 0 means there is no diabetic. That to find out. Okay. So I am going to the logistic model where I am having the matplotlib, then Panda, then OS. I am getting the change directory as os.change directory with data set. Then I'm going to read the diabetic data set. Then let me see the data set, how much data available. Okay. So if you see 768 rows and 9 columns, 768 rows and 9 columns, right? So what I'm going to do, I'm going to take independent variables. So what are all the independent variables? Independent variables are pregnancy, glucose, blood pressure, skin thickness, then insulin, BMI, diabetic pedigree function, age. These are all what is called independent variable. The outcome is the dependent variable. So based on this value, that outcome will be calculated. Okay, on this value, outcome will be calculated. Then I am preparing independent data frame with these following values. Okay, dependent value is this. So independent head, if you say, if you go and get it, okay, both. Right, I can have a, this is the data for dependent variable. This is data for dependent variable. It is all 8 columns. Then once I go for dependent variable, okay, dependent variable, then only the output column, only output column, whether diabetic or not, only output column. Okay. Then I am splitting the data as learn train split data set. Okay, scale and train splitting data set. Then I split the data set. Then prepare the model. Prepare the model. Scale and pre-processing. Then standard scalar I am using to fit the value. Okay, to fit the value. Okay, so fitting the logistic regression. Then training the data set, get parameters. So that model I prepared. Prepare the model. I am not going to find the threshold. I set the threshold at 0.5. Then I wanted to see the classification which is better than 0.5. See in this graph. So whichever the value is, so this graph, I am having graph. So here to see the threshold, maybe we can use the ROC curve to find the threshold. Otherwise, we can fix the threshold. In case I am fixing the threshold as a 0.5, but we can find out to find the threshold also. Okay, so I am going to the classifier where x text is equal to classifier. Then that prediction I am doing. Accuracy of this I can do with the confusion matrix. So when I print the confusion matrix 86 0, 1. So true positive, then true negative, false positive, false negative. Okay, this is the value I am getting, right? So no, I am not going to find the actual value. Now I see the display the confusion matrix in the plot. Okay, in the plot I am getting. Okay, in the plot I am getting label. Okay, once you saw that value, so this is true positive, true negative, false positive, false negative. Okay, that way. So we have to reduce the false. We have to reduce the false positive. Reduce the false positive. Ultimately, your precision of your algorithm will be very high. Okay. So compute the precision. You see that the report it will give. So the report over report it will give like a precision, recall, F1 score, and support. Right. So precision is almost 0.84 and recall is 0.8 and F1 score is 0.8. So ultimately I'm getting the good accuracy for this, and you can see the accuracy individually also. You can get the report as a classification report over for Y test and Y prediction, as well you can individually pass Y test and Y prediction for each accuracy score and precision score and recall, but also you can get the value. So accuracy score here, what I can get it, sorry, 0.75 accuracy score, then precision is 0.59, then recall is 0.65, like I'm getting that value. And now I'm preparing the ROC curve. The ROC curve will give where exactly I can put it, but ultimately if you see this, you can get that how to, for example, this is the ROC curve. So in the ROC curve, I want to reduce the false positive, increase the true positive. Okay, so reduce false positive. Once I wanted to do, where exactly the curve become at one point. For example, saturate. So where the curve will saturate. See, if I wanted to increase the true positive, then I can put that almost to 1. Okay, 0.2. Okay, 0.2. If I put this one, then if I go this one, then ultimately it is true positive is 0.67, something like that. So I want to increase the true positive also. Once I want to increase the true positive, I am having that value I wanted to have almost. That is the reason I got 0.5. That is the reason I got the 0.5. So here you see, if I put this false positive as 0.5, then almost I can get the 85%. So that way you have to increase it. At the same time, I have a false positive 1 means completely what is called your system will not give the proper output. So this ROC curve also you can check and you can verify whether you're able to get the proper output or not. So this is can fix the threshold also. This is the way you can fix threshold. Okay, so that way you can do. Another one is I wanted to see the data for. I want to see the data for what is called the real estate. I mean, the market, how it is giving the time. Okay, that you can show the credit card fraudulent or credit card fraudulent data. So credit card fraudulent data, credit card. Okay, so in the credit card, you see that you can have a data. Actually, this number of rows are very high. I wanted to see that whether it is a fraudulent or it is a right. Okay, so almost 28,000 rows are there. Almost 28,000 rows are there. Maybe it takes some time to open the Excel sheet. It will take some time to open in Excel sheet. It is available in the Google site. It is available in the Google credit card. Okay. So if you go to credit card fraud Google, it is available that data set. Okay, you can download the 51 MB data set, right? If you see the data sets there, credit card data, 1 minute. If you here itself, you can see that one, what columns are there. Okay, then column, what all the columns are there. So these are all the number of columns are there, and then V2, V3, V4, like the columns and the relationship of each. Exploratory analysis also you can provide. Analysis also you can provide with the data set. Okay. Let me check whether it is loaded or not. Yeah, it is loaded now. Okay, it is loaded now. And for this data set, I want to find out whether finally it is a fraudulent or it is true. Okay, it's a fraudulent transaction class. So finally, it will talk about the amount and the class which. So maybe one is fraudulent transaction. Someone is a fraudulent transaction. To find out, now I will run the program. Then you can see that one. I am not going for line by line. Line by line already I have explained to you. For example, if with this, then I will run this algorithm. You see that one. Yeah, this is a description or description of the particular, right? Then I wanted to have this exploratory analysis. You see, I wanted to put that algorithm. I have a normal distribution in all the places. Whatever, when I have a histogram between V5 to or V6 or V7, V8, for each column, almost I'm getting the positive skew or negative skewing or normal distribution. So almost the data fixed here, almost data properly fixed here to proceed with the logistic regression. Okay. Then further, I wanted to see one. So last. Okay, exited. Yeah, histogram.png. Then heat map I can bring. Heat map I can bring. Then get it. Multiple logistic regression I can provide. Multiple logistic regression. If actually that is to load digits. I will give you the load digits. Load SNS load digit data set. Actually, if you see digit data set in the SNS scikit-learn, here what will happen? What will happen? The problem is I have one kind of an image. I have a kind of an image. So the image I wanted to take it as a whether that actually 8-bit matrix. That image, what kind of image? That is actually the image is not some number 0, 1, 3, 4 like that. I wanted to know whether based on the image I wanted to predict whether that image is with the 0 or the image is with, that is what. So multiple class. It is not only one class. It is having the multiple classes. So that multiple class, if you wanted to see at one multi logistic where I can have a plot here. I am reading the data from load digit. Okay, digit SN, this is available in the SNS. Okay, so DIR of digit, these are all the description, these are all the description, that is a few names, frame, images, target, frame. So now I put the DIR of this one. Then maybe for the zero data, I can put the gray, not dot. So this is the this is the thing. So this kind of image I have, from the image I could understand that what is the value within the value. Actually, there is a column. The image along with the data is available. The image along with the data is available. For example, if I go with the head, okay, digit head, digit start head. Okay. Actually, since it's an image value, if I put the yeah, here itself we can understand. Yeah. So here you see target name is also there, target is also there. So the image, I can understand it's a 0 or it's a 1, like I can get it. So images of 0, images of 0 is what you have seen. This is the images of 0. So what is the target value? The target data. So what is the data? The data is this is the, so 0 is the target data. First 0 of 0 data. Like I am running the 5 images, 5 data you can see. Okay, images, then 5 data. 5 images I can PLT that show. PLT I can put here. Okay, so try into this one. I not defined. Range all 3 lines. Enter. Yeah. So this is what is called one graph. Then this is the one. This is maybe I do not know, 2 or something. Then this may be looking like something like a 3 or 4. Then this 4. Okay, so there is a, what is the value, exact value from the 0, 1, 2, 3, 4. So 0, 1, 3, 4 only we have seen in the form of what is called the images. But base image, I have to find out what is the value for the regression model. Okay, so now if I put this, just I am running the program, you can understand that even that logistic, I mean, multi-class regression also you can do with that one. Class regression also you can do that one. Okay, so I'm fitting the model, getting parameter. Okay, for 67. Okay, so 67 when I plot, this is a 67th one. This is a column number 6. So 67th row, there is a image is there. This is the image. Then what is the target? Target is 6. So we'll be able to understand. So this is the predicted. So that exactly or not. It's a 6 as it's looking like 6, but my model whether it will predict or not, that will show to you. So my model predicting exactly that value. Okay. So suppose like you can predict that one. So fit model with that value. So I'm creating the confusion matrix. So the confusion matrix will say that predicted value with the truth, plt.show. So for example, if you see 0 is predicted almost all the way. Okay, then 1 actually you see 2 times is the truth, 2 times wrong. It's predicting the truth is 8, but it is predicting something else. Right? Then for 6, predicted is 1 for the 6. Then for the 2, this is a predicted, it's predicting as 2. Which one? For 8, it's predicted as a 1 occurrence. Right? Then 2 is predicted as a 2 occurrences. 1 is predicted as a 131 occurrences. 0 is predicted as a 27. Exactly. Okay, so this is highly predicted. You see 40 is highly. So 6 is predicted as a 6 exactly. Actually, this is the value exactly. But you see, for example, in this case, 6 is predicted as a 1. Okay, how many? Only 1 occurrence. Then 5 is predicted as a 9, only 1 occurrence. So almost the heat map shows that your model is having the high accuracy. The model is having the high accuracy. All the are predicted absolutely, maybe 1 or 2 occurrences. 9 is predicted as a 5 at the 3 times. I think this is the most highest wrong occurrence because this is 3 times it's wrongly predicting. Then other things are 2, then 1 only. So maximum is 3 times wrong prediction is happening. For 9 is predicted with the value as a truth is 5, but it is predicted as a 9. So this heat map, the heat map will show us that how truth and that value will be. So like you can find out how it is a predicted transport value, whatever the image you give, particularly this kind of image, how it is a prediction will do. So that we can have a classification. So now I think like, what is called, I will stop share. You can have any kind of algorithm are there. Maybe I started with a very basic algorithm. If you for ordinal classification also, you can one category, under that category you can have some subcategory, like that kind of ordinal classification also you can go. Then classification, for example, polynomial classification, again you can plot that value, and based on that value you can see whether that classification, I mean that regression is polynomial regression or not. Like you can work with the different data set. Maybe historical, I mean some real data sets are available. I will you can try with this. You can try with one called iris data set for logistic multi-class logistic. Okay, for example, iris data set. If you take iris data set, okay, maybe you try with the iris data set. Actually, this is the image of the flower. The image is the petal, each petal length and width. Based on that length and the width, whether that flower is setosa or there are 3 classifications are there. If you see the data description, you can see whether the data. Yes.
Sir, actually your screen is not visible, sir.
Oh, I see. Okay. Maybe you can try to do this exercise. Maybe you can do that exercise. So what exactly is actually based on the I think now this is the flower. So based on the flower sepal width and height, you can see that the flower is whether in the class of setosa or class of versicolor or the class of vesica, like you can find out. So these are all the 4. Sepal length, petal length, petal width. Like there are 4 parameters are. Based on the 4 parameter, you can pick any class of this flower that you can find out. Okay, so you can see that maybe 2 classification you can do, maybe one SVM, or you can go with the what is called logistic regression, which regression to the accurate value you can find out. Okay, more precision that you can find out. Like there are many things are work on it. You can try to do that algorithm. You can try to do that. Okay, fine. So with this, I will conclude my session. Thank you so much for your patient listen. Okay.
Thank you, sir. Participants, if you have any questions, you can put it in the chat box.
If you work then
now the chat box is enabled. You can put the question in the chat box. And one more announcement: after the questionnaire session, there is a photo session. At the time, you can on your camera, and we can have a photo session after the questionnaire session. And the feedback link will be given in the session 2, and the attendance link also will be posted in the end of the session 2.
Good afternoon, sir. This is Padmavi.
Actually,
thank you so much for accepting the offer, sir.
Yes, ma'am. Actually, one point, madam.
Yes,
missing value remove from the data set. You can remove from the data set. Missing values are there. You can remove, or you can make some standardize that value. Okay, that we can. Actually, I have shown that in my logistic regression, I will share the program how I replay the value that type. Thank you. Yes, madam. Yes, please, madam.
Yes, sir. Thank you so much, sir. The session was very informative. I hope the faculty members and research scholars clearly understood the concepts. Thank you so much for accepting the offer, sir.
Thank you, madam. Thank you.
Please join the second session. Please enable your cameras so that we'll have a. Please. Thank you all. Thank you, sir.
Thank you, madam. Thank you. Thank you.
Participants, you can join next session at 1:45 p.m. The next session topic deep learning by Mr. M. Vignesh. Thank you, and join next session at 1:45 p.m. Thank you.